What is the molarity of sulfuric acid that will completely neutralize potassium hydroxide, a base, if 10 milliliters of the sulfuric acid reacts completely with 15.9 milliliters of 0.15 molar potassium hydroxide solution? So, we have to look at this acid-base neutralization reaction. We're going to need to write out the equation. And so, we have our H2SO4 combining with the base KOH, and they make water, which all acid-base reactions do, and a salt, or an ionic compound, same thing, in this case K2SO4. First step in all stoichiometry, always, is to balance the equation. And so we put a 2 in front of the KOH and a 2 in front of the H2O, and we are done. Next, let's write out what we have here. We have a volume of our H2SO4 of 10 milliliters, and we have a volume of our KOH of 15.9 milliliters, and we also have a molarity of 0.15 moles per liter. So, second step in stoichiometry is to find the moles of the thing that you know or have some information about. And so the 10 milliliters of H2SO4 doesn't really help us. There's not enough information there. But the volume and molarity of the KOH gives us a way of finding moles, since the formula slant-em equals N over V in liters can be rearranged to M times V in order to get a number of moles. However, because of the definition of molarity being moles per liter, not per milliliter, we need to convert the 15.9 right away. So divide by 1,000, and we get 0.0159 liters. Let's convert the 10 milliliters of H2SO4 as well right now while we're converting, because we're not going to be able to use milliliters later on either. And if we divide that by 1,000, we get 0.01 liters. So now we can find our number of moles, and it's going to be, of the KOH, it's going to be 0.15 times 0.0159, and we get 0.002385 moles. So now that we know a number of moles of our KOH using the mole ratio step, which is common to all forms of stoichiometry, we can figure out how many moles of H2SO4 we have. So if we set up that ratio, it's a 1 to 2 ratio when we look at the balanced equation coefficients. And we're looking for the H2SO4. So if I multiply by 1 and divide by 2, I get 0.001193 moles of H2SO4. Now that I know my number of moles of H2SO4, and I know my volume in liters is 0.01, my last step to figure out the molarity is simply plug those two things into the molarity formula. And I get 0.001193 all divided by 0.01, and my molarity of my H2SO4 then is 0.119 moles per liter. Now, if you've been paying attention in class or on some of the last solution stoichiometry video, you'll notice that this question is actually the exact same question or example as before. The only thing I changed was the word that will completely neutralize potassium hydroxide. I just added that to the same question. The reason why I did that is to just point out that acids and bases are just solutions like any other solution, and so the stoichiometry or the chemistry and the mathematics of analyzing those things is the exact same. So there's no difference.